All right, Algebra 1A students. Welcome to part 1 of lesson 1.7. Today we're talking about the distributive property. And the distributive property is something that helps us to rewrite expressions in a simpler form. We're going to use the distributive property to rewrite an expression with no parentheses. Okay, that's going to be our goal. So the distributive property basically says if you have a number being multiplied in front of two numbers added or subtracted together, b plus c or b minus c. If you have a number multiplied in front of two numbers added or subtracted together in parentheses, we can just multiply a times the first number and a times the second number and write it without the parentheses. So we write a times b plus a times c. Okay? For example, if we had 4 times 20 plus 6, we would do 4 times 20 and 4 times 6. 4 times 20 we know is 80, and 4 times 6 we know is 24. So I've rewritten this problem with no parentheses. Now it just says 80 plus 24, which is something we can probably deal with much easier and nicer than 4 times 20 plus 6 in parentheses. Okay? It also works if you have a number multiplied after two numbers added together or subtracted together. So we can distribute backwards as well, a times b and a times c. Okay. This is a process that I call doinking sometimes, because that's what this reminds me of. Doinking, like when we do a times b plus c, doink, doink, a to the b, a to the c. I call it doinking. Okay. Now, if we look at an example, or a couple examples, they're asking us to simplify here in letter A, 3 times in parentheses x plus 8. Well, this is a number multiplied in front of two numbers added together in parentheses. So I can just distribute the 3 to the x and to the 8. 3 times x, 3 times 8. 3 times x we don't know, so we just leave it as 3x. 3 times 8, we do know, that's 24. That is as simple as we can get it. There are now no parentheses, and if we had a value for x, we could solve that very easily, or simplify very easily. Okay? So what we're doing is really rewriting things with no parentheses, especially when we have variables involved. Okay? In letter B, I want you to notice that they have a negative 7 at the end of 5b minus 4. So there's two numbers here that are being subtracted from each other. So I'm going to take the negative 7 and multiply it to the 5b and to this minus 4. Okay? So they do a 5b times negative 7. 5b times negative 7. And we can't multiply the b here, but we can multiply the 5 and the negative 7, which leads us to negative 35b. Negative 35b. 5 times negative 7 is negative 35b. And then the second part, they do a minus 4 times a minus 7. Negative times negative, well, that's a bad guy leaving town. That's a good thing, so that's a plus. So that turns into a positive 28. Okay? Positive 28. So my simplified answer with no parentheses and putting together everything that I can, I get negative 35b plus 28. Okay? I would like you to try a few of these. I'd like you to try A, B, and C here. Pause the video and try to distribute these numbers, the 5, the 12, and then the 3 from behind. And then once you think you have answers for all of those, come on back and I'll show you what we should get. Okay, in letter A, we should get 5x plus 35 because we do 5 times x and 5 times 7. In letter B, 12 times 3 gives us 36. We're subtracting then. 12 times 1 over 6 is 12 over 6, which simplifies down to 2. And we have a t on there. 36 minus 2t. And then in letter C, 3 times 0.4 gives us 1.2. This is a plus sign. And 3 times 1.1 gives us 3.3c. Okay, so I get 1.2 plus 3.3c. We should have those three answers for A, B, and C. All we're doing, as I mentioned, is doink, 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 and then backwards, doink, doink. Okay, just doinking there. Now, we can also distribute a negative sign. Now, when we distribute a negative sign, the key for us is this is like a negative 1. Okay, it's like a negative 1. So distributing a negative sign is like a negative 1. So if I had a negative 1 in front of some parentheses, like if I had a negative 1 here, then my distributive property would be just the same. I would take negative 1 and times it by 2y. I would take negative 1 and times it by minus 3x. So negative 1 times positive 2y gives me negative 2y, right? Negative 2y. And negative 1 times negative 3x, or times minus 3x, well, minus and minus make plus when we multiply. Bad guy leaving town. 1 times 3 gives us 3, and I can't do anything with the x. I just leave it on there like that. So I get negative 2y plus 3x. I basically made the 2y negative and flipped the 3x back to positive. I would choose letter C here. Okay. So distributing a negative is like distributing a negative 1. So just pretend there's a negative 1 there. You can even write it out if you want to. Put a negative 1 in there for a negative sign and then distribute like normal. Okay. Now the last thing we have to do is distributing over a division sign, okay, which a lot of times is going to show up as a fraction. So we'll have problems like this. They want us to write an equivalent expression for this crazy looking thing here. On the top of this fraction I have 7x plus 2, and on the bottom I have a 5. Okay. I'm actually going to distribute basically over this divide symbol or over this fraction bar. Okay. So what I'm going to do is I'm going to take the 7x that I see first, and I'm going to divide it by 5, or write it as a fraction over 5. And then I'm going to take the positive 2 that it's attached to, and I'm going to write that also as a fraction over 5. Okay. So what I'm going to end up with is I'm going to end up with 7x on the top of a fraction with a 5 on the bottom. And then I'm going to have a plus sign, because that's what I had in my original top value, right? Right here I had a plus sign. So here's a plus sign right there. And then my other fraction is going to be a 2, I got a little big on me, over a 5. So if I were to write this crazy fraction expression as a sum or difference, I would put the 7x over 5, and then I would put the 2 over 5 like that. Okay, 7x over 5 plus 2 over 5. Now we do have to watch out for maybe simplifying these fractions, maybe dividing the 2 and the 5 by the same number and making it simpler. But in this case we don't have to do that because this is as simple as it can get, and this would be my final answer right here. So when we distribute over a negative sign, our answer should end up looking like 2 fractions added or subtracted together, potentially simplifying one of them. 2 fractions added or subtracted. Okay. Now I have a few I'd like you to try. I'd like you to find me a simpler version of each of these. Write it as 2 fractions added or subtracted together. Make sure you simplify if you can, please. Pause the video now, take a look at these 3 problems, and write them as 2 fractions added or subtracted together. Okay? When you think you have that done, come on back and I'll show you what we should get. Okay, in the first one, the first thing I'm going to do is take the 4x and put it on the top of a fraction. And underneath that will be a 3, because that's what's on the bottom of my fraction. And then I have a minus sign. And my other fraction has 16 on the top, because that was the other piece of the top of my fraction right here. And the bottom is a 3. Now, in letter B, I will have a plus sign between the two because there was a plus sign on the top of my fraction. The first fraction is going to be an 11 on the top with a 6 on the bottom. And then here, I would end up with a 3x on the top and a 6 on the bottom. However, I think that's something that I can simplify. If I divide the top number by 3, I end up with just 1x. And if I divide the bottom number by 3, I end up with 2. So I have 11 over 6 plus 1x over 2. And if you don't want to write the 1 there, you really don't have to. You can just write x. Okay? Just write x. Or 1x. Either one is totally fine. And then in letter C, I'm going to have a plus sign in between. This fraction is going to have a 15 on the top and then a 12 on the bottom. But that is most certainly something I can simplify. I can divide both of these numbers by 3. So I'm going to divide the 15 by 3 and get 5. And then I'm going to divide the 12 by 3 and get 4. So that becomes 5 over 4. The other fraction would be 6x on the top and a 12 on the bottom. But that's another one I can simplify. I can divide the top number by 6 and get a 1x. I can divide the bottom number by 6 and get a 2. So again, I end up with 1x over 2. And if you don't want to write the 1, you certainly don't have to. You can just have an x on the top. Okay? Because 1 times x won't change anything. It'll just be x anyway. Okay? Hopefully this is making sense. Distributing not only with multiplying, doinking process as we did on the top, but also we can distribute over the divide, where we divide the first, divide the second. If you have questions about distributive property, the process that we went through, where we're doinking, multiplying 3 by x and 3 by 8, or if you have questions about distributing over dividing, where we make fractions out of the first number with the bottom and the second number with the bottom, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.